So we want the inverse function of f of x. So if we think y equals 4 minus log x plus 2, then swap the x's and the y's around. So x is 4 minus the log of y plus 2. And then what we need to do is rearrange this to say y equals something. So we need to get the log term on its own. So the log of y plus 2 is equal to 4 minus x. So to get rid of the logs, the inverse function is to raise it to the power e. So e to the natural log of y plus 2 is going to be e to the 4 minus x. Log and natural log are inverse functions, so this side just becomes y plus 2. So y is then going to be e to the power of 4 minus x, take away 2. Okay, so part B wants the domain of the inverse function. Now you know that this is the range of the original function, and the easiest way to find the range usually is to sketch the graph. So let's go through the process here of sketching the graph. So I'm going to start off with my basic standard log x graph, passes through 1 on the x-axis. And then what I'm going to do is I'm going to draw y equals log x plus 2. So that's a translation of this graph, 2 units to the left. So instead of passing through 1, my graph is now going to pass through minus 1. But I'm only interested in values of x that are bigger than minus 1. So I don't actually want this bit of the curve, I just want the bit of the curve that's at the top. So my next translation is to make this negative. So making this whole thing negative means I've got a reflection in the x-axis. So this graph here gets reflected in the x-axis to give this one. And then my final transformation is to add 4 on. And adding 4 means a vertical translation of 4 units upward. So my point here is going to move up to a value of 4. And from here then it's obvious what my range is. My range is going to be, or x is, my domain I should say, is going to be x is less than or equal to 4. For those of you who don't like drawing graphs, there is an alternative way of doing this. You know that the log graph hasn't got any turning points, and you know that x equals minus 1 is a cutoff point. So what we can do is work out f of minus 1. Well, f of minus 1 is 4 minus log 1, and 4 minus log 1 is 4. So we know our cutoff point is at 4. All we need to do now is decide whether we are greater than 4 or less than 4. So what you want to do is take a point that's in this range. So let's consider x equals 0, because 0 is bigger than minus 1, and work out f of 0. Now f of 0 is going to be 4 minus log 2, and 4 minus log 2 is less than 4, therefore 4 must be our maximum value, so our range would be y is less than or equal to 4, therefore our domain would be x is less than or equal to 4 as well. So part C wants f of g of x. So what we've got to do is replace every x in the f function with the g function. So we're looking at 4 minus the natural log. Now instead of x, we put the g function, so e to the x squared minus 2, plus the other 2 that's in the bracket. So if we simplify this, we get 4 minus the natural log of e to the x squared. And log and e are inverse functions, so they cancel each other out. So this is going to be 4 minus x squared. And part D then wants the range of f of g of x. So if you think about this function here, if you do a quick sketch, it's a quadratic and it's an N shape, and it's going to go through 4 on the y-axis, so it's going to look like this. And from here you can see that your range is y is less than or equal to 4.